Good morning. Today we are going to see normal and tangential acceleration. So actually this we can say we have motion in one dimension till we have seen. So Civil Engineers Technical Hub, my YouTube channel, and in this you can have engineering mechanics playlist. So you have to go to playlist in which engineering mechanics, and you have number of videos in this. Some of these are shown over here. Now we have actually covered first part of this unit 5, and now we are going to switch over to the second part. So in this we are now going to be with basic concept equation of motion in Cartesian coordinate. We are going to see only Cartesian coordinate. We are not going to be polar coordinate, because when I have with these papers, and in this paper question is not there from your polar coordinates, and therefore we will not go polar coordinates. We will go only with Cartesian coordinate. So now in Cartesian coordinate we have to go with two equations, or I can say with motion we have only in one direction, but we have acceleration in two directions. So in this we are dealt with tangential and normal acceleration. Tangential and normal. So we have two accelerations. Accelerations are two, but we have velocities only in one direction. So we have velocity is tangential. So do not confuse, as we have acceleration 2, so velocity should be 2. No. So tangential acceleration dealt with tangential velocity. So whatever change in the velocity, that change is due to tangential acceleration. What is work of this normal acceleration? This normal acceleration keeps your body on curve. And you remember, this is also known as centripetal acceleration. Centripetal acceleration. So this will keep your body in motion. Do not contribute in velocity change. Do not contribute with velocity change. And therefore, if we will write the equations, or let us, I will consider we have body that is on curve. And in this, if horizontal acceleration is given, then this horizontal acceleration is nothing but normal acceleration. And then we have along tangential, we have AT. In this, we have two axes. One is normal, another is tangential. And then we have total acceleration is root AT square plus AN square. Now, AN is equal to V square by rho. Now, AT, we have different values, as we have seen constant acceleration. And now here we have constant acceleration as AT. Means whatever equations we have, so we have Vt is equal to Ut plus AT into T. We have Vt square equal to Ut square plus 2AT into S. and then we have S equal to ut t plus half at into t square. So things are replaced by t, that is tangential direction, because our velocity along a normal is always 0. And whatever velocity we have, that is along tangential, and therefore we have v is equal to vt. Vn is always 0. If we have v1, then body will not be on this curve, body will come towards the center. And to keep your body on the curve, we should have vn 0, and velocity at any point is tangential to the curve, and normal component of velocity is always 0, and therefore we are always v equal to vt. Now, if my velocity is constant along curve, if velocity is constant along curve, what does it mean? It means my value of at is 0, a is not 0, and in that case a is root of at square plus an square. We have at 0, so this becomes 0, and therefore we have a equal to an. My value of an, this changes from point to point. An changes from point to point. This I will say vt or v, because we know v is always equal to vt. So you have to go with these three equations. So always keep in mind, whatever change in velocity is due to tangential acceleration due to at only. An will not contribute your change in velocity. So now we will see some problems. So that is, a train enters a curved horizontal section of track speed 100 km per hour. Now we have initial velocity 100 km per hour. And then we have this value, that is 27.78. Always find in meter per second. Slows down with constant deceleration. So final velocity is 50 meter per second, kilometer per hour. So we have this value 50 kilometer per hour, and that is equal to 13.89 meter per second. And this becomes in t equal to 12 seconds. An accelerator mounted inside the train records a horizontal acceleration. So we have a, and just I have shown you horizontal acceleration means if you are on a curve and you have at this point horizontal acceleration. So this value is an 2 meters per second square. So we have an 2 meter per second square. When the train is 6 seconds into the curve, now we have given T6, calculate the value of rho. So we have to find rho at t is equal to 6 seconds. We know value of an. We know value of vt, I will say. This will be ut, always tangential on the curve. And therefore I will use whatever data we have, we know u, we know v, and we know t. So we will use vt is equal to ut plus at into t. V is equal to u plus at. And this is 13.89 equal to 27.78 plus 80 into 12. And if you solve this, so we have 80 is equal to 27.78, sorry. So equal to 13.89 minus 27.78 and divided by 12. and we have AT, this is equal to minus 1.16 meter per second square. Now we know AT and we have to find V at T is equal to 6. And we know what is formula? We have AN equal to V square by rho. And here we require VT at T is equal to 6. Now we know AT, we know initial velocity, we can find V. So we have VT is equal to UT plus AT into T. Now we have T is equal to 6 seconds. And therefore we have VT is equal to UT, we have 27.78. AT we have 1.16 and T we have 6 and we have value of VT. This comes 20.82 meter per second. Now knowing this value, we can find radius of curvature. AN we have VT square by rho or V square by rho because we know VT is always V and then therefore rho is equal to V square by AN. We have 20.82 square and AN is 2 and from this we will get rho at T is equal to 6 equal to 216.74 meters. So problems of this tangential normal are very simple. You have to understand it very clearly. Do not try to draw this diagram. You will be confused with this one. So always try to solve the problems. Now similarly, an outdoor track is 126 meter in diameter. So write down rho, radius of curvature, equal to 126 meters. So that is given an outdoor track. So this is a diameter actually. So we have given a track, outdoor track. And diameter is given, means that track is circular. So we have this as given 126 meters. Total diameter. So if we will find radius, then we have radius half of this bay 63 meter. So my value of rho therefore 63 meters. A runner increases her speed at a constant rate from 4.2 meter to 7.2 meter. So initial value we have 4.2 meters. Final value we have 7.2 meters per second. This is also 4.2 meter per second. Then S is given 28.5 meters. And what we have to find? We have to find total acceleration. We have to find A at T is equal to 2 seconds. So now we have to find AT because we know what is A. So we have A equal to AT square plus AN square. Now AT we can find because U is given, V is given, S is given. So which formula we have to use? VT square equal to UT square plus 2AS. AT I will say. Now VT we have 7.2 square equal to 4.2 square plus 2 into 80 and S is 28.5. By using this, we have therefore 80 equal to value I got, that is 7.2 whole square minus 4.2 whole square upon 2 into 28.5 and we have value of 80 is 0.6 meter per second square. Now this is in distance 28.5 meters. Now we are interested to find velocity at t is equal to 2 seconds. So we have to find Vt is equal to ut plus AT into T. Now VT we have to find. T is 2 seconds. And we will get Vt equal to, at T is equal to 2 seconds. Ut we have 4.2 plus AT we have calculated 0.6 into 2. And we will have this value. Vt is equal to 5.4 meter per second. Now knowing Vt, we can find An, which is equal to V square by rho. And we have 5.4 whole square and divided by rho we have 63. And from this we will get value 5.4 square divided by 63 equal to 0.46 meters per second square. Now A we can find equal to AT square plus AN square. So this is at T is equal to 2 and equal to root of AT we have 0.6 square, AN we have 0.46 square. And from this we will get A at T is equal to 2 equal to, now we have to calculate this, 0.6 square plus 0.46 square, and the root of this we have 0.76, 0.76 meters per second square. So this is acceleration, total acceleration at T is equal to 2 seconds. Total acceleration. So likewise, actually, we have to solve the problems. In 3 question paper, we are with 3 problems. So all I have considered over here. Now a motorist is traveling on a curved section of highway of radius. So rho is given 762 meters. At a speed means initial value is given UT 96 kilometer per hour. And we have this value 26.67 meters per second. The motorist suddenly applies the brake, causing the automobile to slow down at constant rate, knowing that after 8 seconds, Vt is 72 kilometer per hour, and that is equal to 20 meter per second, and this happens in 8 seconds. Then speed has reduced to say, determine the acceleration of automobile when speed reduced to 72. Means we have to find acceleration which is equal to AT square plus AN square, and that is when V is equal to 72 kilometer per hour, which is 20 meters per second. Now we have given U, we have given V, we have time T. So we have Vt is equal to Ut plus At into T. Vt we have 20, Ut we have 26.67 plus At into T is 8. And therefore we will get At is equal to 20 minus 26.67 upon 8, and we will get value of At equal to minus 0.83 meters per second square. Now we know At value, Vt we know, that is 20 meter per second, and then we have to find An. So An equal to V square by rho. Now we have 20 square divided by R, that is rho we have 762, and we will get An equal to 0.52 meters per second, that is 400 divided by 762. And then knowing this value of an, we can find a, which is equal to root of 80 square plus an square, and a equal to root of 80, we have 0.83 square. So minus also if we'll take, then also it becomes plus. So plus 0.52 square, and we will get value of a, that is equal to 0.98 meters per second square. So we have total acceleration at t is equal to, sorry, at v is equal to 20 meters per second is 0.98 meters per second square. So likewise, we have to solve the problems. So now, if not subscribed, subscribe to Civil Engineers Technical Hub. And if you like video, like it. If you have any suggestions, you have this as mobile number, and WhatsApp number I have 70388 31674. So now we will stop here only. Thank you. If you want any problem to be solved, or if you want any, if you have any doubt, you can call